So you guys, if you want to listen to the recording later, that's fine. Okay. Display. Okay. Hopefully it should come. It's making some connection. Okay. Yay. So as I said, today we are going to talk about anticoagulation, and these are your learning objectives for today and tomorrow. We'll cover hopefully 1, 2, and 3, 4, some part of like heparin and warfarin. Tomorrow will be all drugs. Today we are going to talk about them. These are all your drugs that you'll be taught today, tomorrow, and mostly in the clinical lectures, these different classes. And so I think I don't know how much you remember from the biomed, we talked about these pathway, but this is basically this pathway of blood coagulation is what we are going to review in majority of today's lecture, so that you know why are we studying this pathway, because there are drugs that we'll be talking that is going to impact this and carry out the anticoagulation. So basically, first we want to understand coagulation to understand anticoagulation impact, right? So this is, say, your body can heal spontaneously, right? If there is any injury, how does that healing process happen? Those are the 3 phases, the 4 phases that we are going to review here. How many of you remember this? Just a
it was
bigger picture.
Your lecture, right?
Yeah. So so you have some idea, right? But let's review it again, because that's what this whole unit is about. So there is a damaged vessel wall, right? So once that happens, there is a cascade of things starts happening. So first, let's review on the left side what is happening, and then we'll review the right side. But they both join in forming the thrombus. So there's a bleeding, right? We have to stop the bleeding, and stopping the bleeding means forming the thrombus. That's our goal, forming the thrombus. So here we have these phases: vascular phase, platelet formation phase, and then the coagulation phase, which is all 3 together is the clot formation. Once you have formed the clot, it's not complete healing is not happened yet, because you also need to dissolve the clot. And that dissolving of the clot is the process fibrinolysis, where then you dissolve your thrombus. So that is the complete healing. So this is the whole big picture. And here, there are many things are happening that we are going to review. And on the right side also is the coagulation cascade that takes place. So that together helps in forming this thrombus. Okay, so we're going to review each step here now. So first, let's look at the vascular phase. That's like, I would say, just end seal, like you're sealing, ending seal, okay? And end means endothelial is playing a big role there, okay, in sealing, forming the seal. So when you have a damaged vessel, this is your primary hemostasis, means right now that is the primary thing that is going to happen right away, okay? So because there's damage in the endothelium, because that's where the vessel endothelial cells lie in the vessel, right? So those cells will contract and expose the basement membrane to the bloodstream. So once these cells, the cut happens, the endothelial cells immediately contract, and then it exposes to the bloodstream, and these will start releasing chemical factors. So, and some hormones that leads to the contraction of the smooth muscle cells. And what you need to form is that initially it forms a gooey, sticky kind of substance around and to help the seal the tear. So the tear, the damage has happened, right, to the vessel. So that damage needs to heal. So this is just a quick fix. The quick fix is immediate, it's very fast, so that all this process is happening quickly. Endothelial cells are contracting, smooth muscle cells are contracting, they're releasing factors, and those factors are sticky seal. Sticky, like a band-aid, little band-aid to that. But it's not complete, right? It's not end. So this is just the first step, initial phase. So next So the next what happens is the platelet plug formation. So the seal has happened. Now you need to make a plug, close the hole, kind of that analogy. How does that happen? So the second phase here is platelet. Platelet plays a big role in this phase. So they are, when you're thinking about blood vessel, platelets are all moving around, right? It's not like there is all or none. The platelets are there, but are they active? If there's no damage, they are not active, right? They need to be told to get activated. And how is that happen? This is the factor, VW factor. It's also called VWF, which gets exposed when there is whenever there is this primary activation of this happens of the endothelium. So these factors will now tell the platelets to adhere to each other. So otherwise they are not adhering; they are just going around. But they start adhering because of this factor. They bring it together. Okay. And then they may be adhering, but they need to aggregate in multiple. So the more they have to bring many of them together, and they need to stick together, not just one or two or three or four. Many millions needs to come and bind each other, and so that it can form a plug that closes this break. Okay, so that plug formation is because of one, the platelet needs to adhere. Second, they need to aggregate, okay? And also the activation at the same time will happen because of some other factors releasing. So there is adenosine diphosphate, ADP, which is also receptor, like there is a receptor for that, which is critical for their amplification. Means the signal needs to be amplified. Few adhering, bringing more aggregate, and also needs to amplify so that there are many are recruited and brought to the site. And there is also clotting factors that we'll review that's also important for this, and calcium ions. All these are this adhesion, aggregation, activation, leading to plug formation is a process that has to happen for this pathway, for the primary homeostasis, which leads to then clot formation down the stream, right? But before that, it has to also complete the process on the right side, which is now like on the third step, which is the coagulation, right? So we have found the damaged vessel, we have found that all the platelets have been activated, but on the secondary pathway, we have to also initiate our coagulation cascade. And those coagulation cascade requires a lot of different clotting factors. And ultimately, we need to form a fibrin mesh. That is, the thrombus is made up of fibrin mesh. Okay? So that forming of the fibrin mesh is where this whole process is going to take place. So that fibrin is formed, which is insoluble, and there is fibrinogen in the blood all the time, but it's inactive. So fibrinogen needs to be activated using thrombin. And thrombin is also there in your blood, but it's in the inactive form, which is prothrombin form. Okay? So these cascades are critical for it to form thrombus. If anything goes wrong here, there will not be a thrombus formation, there will be excessive bleeding. You cannot stop the bleeding. So some patient may need help, right? So this is the physiology. We're not talking about pathophysiology, we're talking here physiology. How does the body heal? So that is the process, the cascade we are going to talk about. And this cascade has 3 different pathways. This is a pathway, but within the pathway we have more detail inside another pathway, seated. So that is the extrinsic, intrinsic, and common pathway. We reviewed that in biomed too. So here, again, when we talk about these, let's now review the clotting cascade. Let's take a look in more detail because it's important for you to understand what factors will lead to what. So before we talk about the pathway, let's review the components of these clotting cascade a little bit more. So the factors actually are in your blood, but they are in inactive form. So these inactive form, scientists likes to assign how to represent inactive and active forms, right? So inactive forms are without an alphabet. They are like numerical Roman numbers. So here 2 is inactive, whereas the 2A is active. Okay, so if you see an alphabet next to a numerical, then it's understood that it's an active factor. Okay, when I show you the cascade, you will be able to see them how from an inactive it can be converted into an active form, and it's an enzymatic process. Majority of that is an enzymatic, and majority of them are serine protease. Just one is not a serine protease. I'm not going to ask you to memorize any of this, like which one is a serine protease. All I want you to understand, this is an enzymatic process. Okay, and also they require cofactors. It can be protein or calcium or vitamin K. Those are the cofactors for this process we need. So here, which we are showing, I'm showing you a factor 2, which is the prothrombin, also called prothrombin, which is the inactive form. And this when it needs to get converted into active form, factor 2A, there is a process here. So the activated platelet will form a complex with another factor 10A and also another factor 5A. Only then it gets converted. If this is not forming a complex, this will not happen. Okay? And this will only form a complex because it has received the signal earlier that there is a break, right? There is an injury has happened to the vessel, and we'll come back to this thought in a bit, how that will happen. So I also want to mention here, like I already said, these are enzymatic factors, and there is another factor 13, which is not a serine protease, but it's more transglutamase. It's good to know information. I don't think there is a drug that distinguishes between the two, but I just wanted to mention that here. And also 2, 7, 9, and 10. So 2 plus 7 equals 9, and 10 are vitamin K factors. So if you want to memorize it that way, it's easier to say 2 plus 7 equals 9 and 10. They are the vitamin K dependent, and they also bind calcium. And this is necessary for these factors activity. Okay? Think about if the patient is deficient in vitamin K, or if calcium has some issues in these patients, how would that impact these activity of these factors? Just a food for thought. Okay, so think about, like, say, if you do a blood test on a patient and if it comes low on vitamin K, how would their healing process happens? If there is any excessive bleeding, how would that impact? So there is also, as I said, non-enzymatic cofactors like, say, 5 and 8. In these, how do they form active? How do they get activated? They have a little different process. It's not like enzymatic, so it's not cleaving, but they find their partners. So like here, say platelet, how does it get, like how does this have play a role in the activity of these 5A and 10A? So when platelets are activated, it will find its partner 5A, which is active factor 5. And once it binds that, it tells that it is receptor. So this receptor gets activated. And that receptor will bind another partner, 10A. So now this whole process is active. Similarly, here is showing that the platelet can also bind 8A. So that becomes a receptor for this 9A to bind.
That's gonna activate, right?
So this whole, you'll see in this why, how this will be critical. I'm just showing two different enzymatic way and also non-enzymatic way. So when you see the pathway, you'll be able to understand which one is happening as an enzymatic process, which one is happening as a non-enzymatic process. In this case, there's no cleaving here, it's more binding that is activating that process. Okay? So this is a table. I don't want you to memorize things, but I wanted to list, there are so many factors, and some of them have names, but some of them, like, the names are too weird. So some are heavily used, like fibrinogen, which is also clotting factor 1. Prothrombin is also clotting factor 2. So when you see that, maybe in NAPLEX, I'm hoping that they will either give you this or they will give you both, so that you will be able to know, like, which one is which. Okay, but I wanted to give
Only
you
those two we have to memorize the name, right? The other ones are like numbers.
So most of them are used in numbers, but I think what I've seen is thrombin, fibrinogen, and I've never seen calcium referred to as factor 4, but scientists give numbers to each of these because sometimes these are harder to memorize. I think I rather have factor 5 and not memorize these whole names there. And the tissue factor, yeah. So this one also is mostly used in names instead of factor 3. But if you see tissue factor, that is factor 3. Okay, so don't get confused, or having like few of them is good, But the other ones, I would point out that factor 10 is really critical, is the central to the pathway. Because that's where all the common pathway, which we will talk about. And the other thing I want to point is, where are they made? Majority of them are made in liver, right? Except for the tissue factor, which is understandably in the endothelial, right? But majority of think about if the patient's liver is not functioning properly, how would that impact all this factor production, synthesis, activation? So keep that in mind when you have a clinical cases, when you discuss that. And also all this, I mentioned that some of them have vitamin K, right? Dependent. So like 2 plus 5 equals 7. No, 5, 9 and 10, right? 5 and 2. 7 and 2. 7 and 2. I forgot my own.
7 plus 2, 9.
So, yeah, I forgot my own.
2 plus 7.
2 plus 7 equals 9. Yeah. So those are the vitamin K. It's afternoon. I need a break too. Okay, so 2 and 7 equals 9 and 10 are the vitamin K. Okay. So what is this vitamin K? Why are we talking so much about vitamin K? So it helps in the post-translational modification of some of the amino acid, glutamic acid residues that are found in these. These are nothing but protein. Okay, we are saying these factors, but these are all proteins. Proteins has amino acid. They are the building block of protein, right? And those amino acids can be modified. So what vitamin K helps in, it enables this forming the carboxylation of these glutamic acid. And without this, these modification will not happen and it will not be able to participate in the coagulation cascade. So that modification is a crucial step. So whenever you see a patient which doesn't have or they are deficient in vitamin K, then you will know that these proteins are not getting modified. Like their glutamic acid is not getting carboxylated. Okay? So that is why they will not be able to, they won't be active and they will not be able to help the patient heal. So just keep that in mind. So now is our complex pathway. There's a lot of things leading to a lot of things, right? But what I want you to focus is, this is listed this way. Let's start from here, bottom. Okay?
Dr. Dia,
Yeah.
I have a question.
Yeah.
In the second step of the pathway, right, you put that it forms like the ADP to the coagulation of the platelets.
Coagulation, no, aggregation.
Aggregation, exactly.
Yeah.
And serotonin and TXA, I think, it's in that pathway too or not?
Serotonin?
Yes.
But,
It's because we have this in the second exam of this class, and one of the topics says that it's ADP, serotonin, and TXA.
I said a lot of chemical factors, but I didn't mention serotonin because I didn't know you needed that for this.
Okay.
But like it is, serotonin is also part of that.
Okay.
Yeah. Coming back. So here is our endothelial, which is damaged, right? So we said we are not talking about any of the primary homeostasis. We are talking about the secondary homeostasis. So here, if once already the platelet has been activated, already the plug formation has happened, now we are going to do the coagulation cascade, okay? So this pathway is only coagulation cascade. The primary hemostasis has already happened. The primary pathway is already activated. The endothelial cells and platelet formation is already happened. So now the tissue factors are released, which is factor 2, right? So it's been released, and now the activated platelets are going to go and tell. It's just like this 2 different pathways are initiated. So the extrinsic pathway is the faster pathway, which happens within few seconds, okay? Followed by the intrinsic pathway, which is like longer, it takes longer for that to activate. So immediately when these activated platelet sees the tissue factor, it feeds into this extrinsic pathway where it's going to activate the factor 7 and needs calcium for that, and actually it's factor 7A which is active, will go and feed into this common pathway. But before we do that, let's also look at the intrinsic pathway when we come back to the convergence of the 2. So here, the collagen is also exposed, right? When you have an injury, the collagen is exposed, and with the platelet and red blood cells, you are going to the exposed collagen goes and activate these factors here. I'm not going to like say that you should memorize all of that, but what you need to understand is all these factors are needed, activation is needed to feed to activate this 8A, which together with 7A is going to activate 10. And factor 10 is the one which is central to this pathway, okay? So factor 10 activation is really critical. So, and they both get activated through extrinsic and intrinsic pathway. This takes longer because you can see there are many factors needs to be activated before the 8A gets activated. But here it's quick, as 7A is quickly activated, 7 is quickly activated to get into this pathway for activation of 10. Okay, so 10, factor 10, when it's activated, this is where all the magic happens. The magic is the thrombus needs to be made, right? So in your blood, prothrombin is already existing. Prothrombin is existing, but it's not activated. And how it gets activated? By through these two converging pathways. So once this gets activated into thrombin, this also needs calcium and vitamin K as we need. We know that. Keep in mind all the factors, right? 2, 7, 9, 10, right? So wherever you see 2, 7, 9, 10, they need vitamin K to get activated. And also calcium is important there for that activation to happen. So now we have thrombin. So thrombin now acts on fibrinogen. Fibrinogen is a soluble fibrin. So soluble fibrinogen is going around in your blood. But since the thrombus needs to be formed, so this thrombin, which is activated now, is going to cleave fibrinogen, leading to fibrin formation, which is insoluble. So insoluble, this insoluble fibrin come together and forms a mesh. And that mesh is the critical formation of the clot, or critically forming. So is this now clear? And this is all you need to know for this particular, for our discussion for the drug. This pathway will keep bringing it back. Okay. So another thing I also wanted to mention here is there's also thrombin bursts happen, because you don't want only a little bit of thrombin, you want a ton of thrombin. So this factor 10 there's a positive feedback. You have to produce a lot of factor 10 so that you produce a lot of thrombin. Okay, so there's amplification of that, and that's why there's a feedback here. So you have a lot of thrombin. There's too much thrombin burst that helps in the formation of fibrin, because you don't want to make a little bit of fibrin. You need to make a ton of fibrin, right? Based on how big is the injury. Right? So, but still, you need to amplify this pathway. So, as a pharmacist, you want to know, how do you understand this pathway? What can you do in a lab to understand where the pathway is impaired? So, there are two different tests that you can use to understand whether the intrinsic pathway is impacted or the extrinsic pathway is impacted. Okay? So which one is faster? Extrinsic. And the intrinsic is slower, right? So prothrombin time you can measure, and also you can measure the partial thromboplastin time. So prothrombin time, PT, tests the extrinsic and the common pathway. If anything wrong with the extrinsic, this particular test will tell you about that. Whereas the PTT will test the intrinsic and the common pathway. So extrinsic pathway, say if anything was wrong with factor 7, that pathway will be prolonged, right? if anything wrong was happening with factor 8, 9, and 11, the intrinsic pathway will be prolonged. So based on what you get from the lab results, you will be able to identify where the problem exists. Okay? So when I right now discussed is 1, 2, and 3, because we only did coagulation, this signaling pathway right now. So, but then, is the healing happened yet? No, right? What you have to do is dissolve. You have to dissolve the clot. So that fibrinolysis has to happen, which is the ultimate fourth linkage in this whole pathway. Coming back to that, in this pathway, there is another protein and factors involved, okay? So here, you actually needs plasmin. And the activation of plasmin happens because in the blood, you have inactive form, which is plasminogen, okay? So the plasminogen, in the presence of plasminogen activator, will convert into plasmin. And this plasmin will now act on the insoluble fibrin to dissolve it. So this plasmin will break down your insoluble fibrin and the clot will dissolve. And that's how the wound healing happens. Okay. So now open the review questions. Let me see what time it is, 2:16. So how we will do this? You have access to these questions. So now I'm not going to lecture. So you will review these questions in your group, and after let me see how many questions are there. So it says it's divided into before the break, like in your PowerPoint, if you open, it says before the break. Those many questions you just review among your group, and then we'll discuss that. These are based on the concept that we just discussed. Everyone has access to that? I want people talking.
All right, guys, number 1.
It's within your group. Yes. So there are 7 questions.
Extrinsic pressure. So it's I referred to this one. Vitamin K is.
So there are 7 questions. So all of you within your group discuss those 7 questions, and then we will, in like few minutes, maybe.
I know it's not translation.
It's not by
So what's translation?
Because like that's the last like product we give before the class. It's necessary.
So 5, 6, and 7 is kind of a clinical based scenario. So other ones should be simpler. 5, 6, and 7 is what we need to.
IB is
Yeah, binding of calcium activity. So A, B.
Then the section. So it's just in between platelet adhesion and platelet.
Synthesis. Yeah, A and B. Is it cleaving or?
Join the group, whichever group you can join. We are just reviewing questions.
I think it's
A and B. I think it's A and B. I don't think about the
That's the
synthesis.
Activation,
It might be.
intrinsic, wasn't that like with collagen?
I don't think for D. It's just say
Possess cofactor
independent.
Okay.
So yeah, let's skip that for now. It's A and B for sure.
But let's go over the one that you just mentioned. How is intrinsic activity?
I think you're right that it's the concept.
Yeah.
Doesn't matter. As long as you know that you are doing it.
That's what it almost looks like where it has like the intrinsic at the very bottom, collagen shows the intrinsic.
That's why few of them I kept it.
Oh wait, no.
Yeah.
Fibrinogen is the enzyme.
Want to know what the station is.
Thrombin is what you need to make fibrinogen. So coagulation
So
cascade.
this is what we will not say 510.
Yeah, it started
So, but I want to tell you.
from here, right?
But this is what.
Is it coagulation phase is this.
From yeah.
He's on this one.
Oh, no, siempre activated
Ah, yes.
cellular damage and then then the primary one. Yeah.
So
This group is a little quiet.
We're just the question, I have the diagram.
C.
Oh,
Wait, why was the
Final step in correlation.
You're not going to work in silos.
Yeah, because first, before I bring this to the, that
I know
part,
you
it
want to
does.
work in silos.
Yes.
And then you get to the fibrinogen.
Sometimes you
No, because you need the 10A for that to convert it.
But I think what you say, the drug
That's right here.
Yeah.
Sorry,
actually said like A. So it's not a drug, X is not fast factor.
Yeah, it's not factor. That's why.
The thrombin
Oh,
no. Yeah.
Sorry. The drug X is not
That's
factor
trying to
X.
explain how it comes to be.
So this is thrombin, and we need to make fiber. If we don't have thrombin, we're not gonna. I think.
It's not factor 10. So drug X is not factor 10. Drug X is
So I'm
ABC, whatever.
thinking like polymerization of fibrinogen. C.
Because it's like thrombin.
Because we already went
Thrombin.
Yeah, we're already talking fibrinogen activation. And we need to make fibrin to have that.
Yeah, like that. I think it's needed for
walk it back to
You want
Yeah.
to bring yourself, because we have another one. So I want more discussion rather than.
something about okay, X inhibitor, inhibitor.
Which point is that?
The release of graduate content.
Yeah.
I think A. Probably
The
B.
thing is the
Activation on the changing
There's no
Yeah.
clear reason.
I think it's because it's
I think it's drug X because
Low molecular.
it's
Low molecular current.
the biggest right?
Wait, this set of questions says 1, 2,
Oh, trust me, I'm not looking for answers.
You know what?
Just laugh.
That's crazy.
So that question.
Yeah. Kill a lot of people. I'm looking for
any platelets to adhere or
that when you use this, so are we doing
no, that's the second part.
Your only responsible right now, I just said that. So, so it's done with all the question 1 to 7?
I'll trust you.
Question 1 to 7, if someone has not done, raise your hand.
We're done with seven.
Yeah, we're done.
Okay, you're done. What about group 2? No.
We have 2.
3. Yeah. You done with the question 7? 2 more questions? Okay, another 5 minutes. So how about here?
So it's free.
Huh?
We still have 2 questions.
2 questions,
Yeah.
the last 2 ones?
Yeah.
Okay.
Okay, so for the
Yeah, I think it's. I think it's perfect.
Let's discuss.
Sorry.
Yeah. I think the one is A. Oh, sorry, the other one to say the B to Y. There's 7 questions.
it's okay.
What words do I haven't heard.
Okay, everyone done? Yeah?
Yes.
Anyone needs more time?
You can just start.
Can start. Okay, so I think Jessica will start.
Okay. Number 1.
A.
Too simple, right? It's more like initiated by tissue factor. It's just a warm-up question. Everyone agrees? Yeah, good? Okay. Tissue factor goes extrinsic pathway. So the second question, who is going to volunteer?
Me.
Okay.
Why are some factors in coagulation cascade dependent on vitamin K?
Okay, this is a select all that apply
I
question.
hadn't realized that.
See, this is something you got caught on. Like I know in the exam you will do the same thing.
No, I won't. I won't. I'll be very careful.
I think a lot of our students think that, and that was specifically put that to
Okay.
wake you up. Do you want to review that question again before you say it?
I have a second suggestion. I am sure of vitamin B being a cofactor for
Vitamin
enzymatic
B?
activity. Like letter B.
Oh, I thought vitamin B. I didn't mention vitamin B. Okay.
But also letter A.
Okay.
B and C, A and B.
What about did anyone catch that? Select all that apply.
Yes.
None of you.
No, we did, it's A and B.
We did. You did too? Or you're just saying it now?
We did. No, we did. I got like 3 circles.
But see, this can be tricked like in your exam sometimes like, oh my gosh, I missed select all that apply. And if you select only one, guess what? You will not get anything.
No,
No partial,
Dr.
no.
Josh?
In Applex,
If you don't get them all, you're gonna get them wrong.
Let's just have no second.
yeah, you'll get it wrong because in Applex they don't give you partial credit. We were too nice to give you partial credit, and we are thinking that we shouldn't because we need to prepare you for Applex, right? Our job is to prepare you for Applex. Also, you need to prepare for the class, but ultimately we cannot be too easy. We can't be parents, right? We have to be very objective about like how we are preparing you. And if we don't do that, you will like ignore select all that apply because you'll say, oh, I at least got my partial credit. This way at least makes you more vigilant. Please take a look at whenever select all that apply, it can be more than one answer is correct, right? So everyone agrees with A and B? So what about C and D?
And B for the liver.
Cleaving, does it require for cleaving?
No, I don't think so.
It's a cofactor, it's not an enzyme, right? So, and it's also not required for the synthesis in the liver. So, yeah.
Yay.
So the next question, this should be very easy. So now I see a hand rising pretty quickly. Okay.
The answer is B, fiber.
No. Final product of the coagulation cascade. Well, there is a like you said fibrin, and I hear no. What are we? Read the question again. What is the question? Read the question again.
Final
Final
product
product.
Final product.
No, is that the question? Final product
of the coagulation.
of the.
Coagulation cascade.
So in the coagulation cascade, where does it end?
The clot, no?
It is five.
Fibrinogen.
Dissolve in the clot?
Dissolving the clot is it part of the coagulation?
No.
That's fibrinolysis, right? So what again? Think about sometimes we jump into the answer, and then it becomes like, oh, did I read the question correctly? Okay. So we are talking about coagulation cascade. Open that pathway, coagulation pathway, and then see.
So it's the
Fibrin, right?
Yes.
That's fibrin.
It's over there. 6 out of 6.
So it's fibrin, right? It's not any other ones. Fibrinogen is inactive. It's not an active. And fibrin is the active form. Thrombin happens. When does thrombin happen?
It's the active form of prothrombin.
Yeah, so which is before,
Right.
right? So it cannot be a final product. And where is plasminogen? Where is plasminogen?
So it's gonna be the thrombin. How it's gonna be the question again? So I don't get confused in the exam. It's gonna say that it's gonna the clot.
The question may not appear this way. It's not like I can replace that into saying when is the thrombin.
thrombin. If I'm gonna choose like the thrombin, it's gonna dissolve the clot.
So you have to look at the
Thrombin
pathway.
is the active form of prothrombin.
Yeah.
It's not the clot. It's not a thrombin.
Okay, now-
It's not a thrombus. Thrombin is a factor, the active factor.
You could have a question saying which factor activates fibrinogen into fibrin, and then the answer would be thrombin, right? Like she's asking like
Fibrinogen
what
is-
kind of question could make.
You can make your own question. Yeah, yeah. That's
It's like she's asking like which kind of question could be answered with
It's up to
thrombin.
you.
That could be a question.
that could be a question.
But you could answer other questions like Shanae
But
said.
is that a good question to ask?
Yeah.
Maybe like yeah. Maybe it's like a simpler recall question, right? Yeah. So how is that process happen? Like, say, what are you trying to gain is like how is thrombin formed, right? So what activates thrombin? That could be a question. What activates thrombin? Then what would be the answer?
Factor 5A.
That's 5A.
So that
5A.
so what factor would activate thrombin? Because prothrombin is inactive, so factor, if you see 5A in the pathway, yeah, that would activate. Yeah.
So this question, can we just say the clot also? Because that's like the final thing at the end of the whole calculation. From
Product,
yeah,
product is, when you say clot is a process.
the thrombus itself.
Thrombus is it's the part of the process, the whole process leads to thrombus.
Yeah.
Right?
The final-
But that thrombus is not happening at this stage of the pathway. So that's the process, not the product. Product is thrombin, those are like protein. Thrombus is a process that that's happening because of all this coagulation cascade. So I think you're getting confused with this. When I say product, I will not list thrombus because thrombus is not a product. So if you are thinking this way, here, right? So thrombus is happening after when we are, fibrin is already produced, fibrin mesh is produced, so that sealing, like thrombus, is like it's not a specific one protein. So when we ask those questions, it has to be very specific to what I'm asking, right? So in this case, we will put thrombin, fibrin, all these are what is saying is the protein. They are different factors. Thrombus is not associated with any factor. There is no number associated with thrombus, right? So, okay, so now which one I still have to do other sections. So let's review this question. Which group has not, your group?
We choose C.
So let's read the question first. A patient with a known deficiency of VW factor presents with a prolonged bleeding following a minor cut. Which step in the homeostasis process is most directly impaired in this patient? And you said you chose C?
Yeah.
Okay. And what about other groups? C? So C is platelet adhesion to the damaged endothelium. So VWF, we know that is the process of the factor. When is it released? It's released by the endothelial cells, right? So if there is a deficiency of VWF, the adhesion is going to be impacted, right? So other ones are activation of the intrinsic coagulation pathway. That's not part of intrinsic. What is it part of? BW and platelet is like outside of the cascade, right? It's not part of the.
cascade.
Huh? It's not in the intrinsic extrinsic. It's like a distractor here, right? It's not part of that cascade yet. It's happened before the primary hemostasis pathway.
Is that distraction?
And the B and B is also not part of this, right? And the dissolution of the clot via fibrinolysis is also not part of this path. So now going back to Jessica, group. You don't have to read this one. Jessica. Thinking of you.
If you put C.
So, an anticoagulant drug A is direct thrombin inhibitor based on its mechanism of action. Which final step of the coagulation cascade is most specifically designed to prevent? So you mentioned it's C, the polymerization of fibrinogen into insoluble fibrin stand. And the reason you chose that is a little bit outside, right?
I was confused if whether the thrombin inhibitors bind before to prevent thrombin or after, but when I saw they bind directly to thrombin, so they stop the next step.
Yeah. So, so the answer. What does other group think? So did you all pick C? Yeah. So in the body you have this inhibitor all the time, but here we are saying a patient is given this drug, which is it's a inhibitor of thrombin. So prothrombin leads to thrombin, right? So, but then once the thrombin is formed, this inhibitor is going to inhibit thrombin. The process is not going to be inhibited. It's the thrombin that's going to go down. Once the thrombin goes down, what is the next step? Is what you need to choose, right? Okay. Huh?
That's C, right?
Yeah. What do you think?
That's okay.
No, I don't want. I don't want to. I don't want to. It's okay. I just want to understand what you mean by. I don't want to just give that correct answer. I want you to help. Like, is there any confusion here? You're good. It's just like where the inhibitors are acting. That's what you need to think about. Yes.
So, should we think about this coagulation, like tissue formation, as it being as it being like polymerizing, but it hasn't been stabilized, like?
So polymerization.
So the next
like,
step would be cross-linking.
Cross-linking is next step.
Next step, and that's when we.
Because think about the fibrinogen is soluble. It's soluble in the blood.
It's like they are stacking together, but they're still like weak, right?
They're not stacking together. They're soluble. Like if you put sugar in the water, it goes like in the solution, right? So they're not sticking or anything. They are just hanging in the solution as a solvent, like so. It's not coming together yet. Fibrinogen is inactive in the blood. So polymerization leads to insolubility. You have to polymerize these soluble fibrinogen to form fibrin. So that becomes insoluble. That is where it's making the mesh. That is where it is cross-linking fibrin to form the stabilizer clot. Is that your question?
Yeah.
Okay. Yes, Kingsley. You had something?
I got it. It's clear.
Okay. Yeah. So I think this is now with the next one, right? Let's go back to our lecture. Why is it not showing? It's stuck. I think it wants to end the class. Okay, I don't know. I may have to restart.
Is this being recorded, Dr. Dre?
Yes, it's being recorded. Okay. But how did you like this process of doing questions? It's better, right?
Yes.
Otherwise, I'll just keep talking and we are sleepy. And I need a break too. So that.
We get like the gaps that we're missing.
Mhm. Oh, hopefully it'll start. Okay. Hopefully it'll. So now we're moving into the next section where all the drugs are going to be fun part of the discussion. Okay. So before we talk about drugs, this unit is about thrombus, right? So we're not talking about just the vessel injury by a cut or by accident, but this is more pathophysiological, can happen as an arterial thrombus or in the venous, right? So there are two different kinds. And what you will also learn in the clinical is this section. You can still remain in your own group. Don't need to move because we'll do more of this after this. So in the case of arterial thrombus, this is what the thrombus will look like. So it has a lot of more platelet. So if there is this, you can see the endothelial cells, there is an injury here, right? If there is an injury, what you will see here in this particular, every thrombus has its own characteristic. So arterial thrombus contains a lot of platelets. And there's a little rupture there, and it also has cholesterol because atherosclerotic plaque. This is where in the arteries happen, right? So you have these more of cholesterol, and also you see some tissue factor. But mainly, this thrombus is made up of platelet, and these platelets are the culprits, or the one that we need to worry about. Okay, so. And the other thing is like this particular happen when the vessel has high blood flow. Wherever there is high blood flow in the vessel, you have a chance of having these kind of rupture. So now we have to treat these patients. So you can't leave it. It can be left a little bit, but the more worsen it gets, you have to get it treated, right? Otherwise, you'll be in trouble. The composition is what I want you to worry about. It has lots of platelet aggregates and some minor fibrin. That's the composition you need to worry about. So the other venous thrombus has, the composition is very different. And here it's located where the blood flow is not as high. Okay. So wherever the venous thrombus may be, sometimes in the legs, you can see these kind of formation of venous thrombus. It's minimal or they are more turbulent. And the composition is largely a fibrin. So, and also it's trapping red blood cells. But they have fewer platelets, activated platelets. So majorly the composition is lot of fibrin. So that is what you have to target. In this case, you have to target fibrin. In the other case, you have to target platelets. So now let's take a look at all the drugs associated with it. So today we are going to talk about heparin, and if we get enough time, we'll talk about it. Majority of the time, we'll focus on heparin. And I think that's also first line of treatment, right? So I want to talk about the mechanism and what this molecule is. What do you think? Do we have heparin in our body? This is like a drug, right? We are talking about drug, but do we have heparin in our body?
Since you're saying it, I guess.
Since I'm saying it is this, yes. We do have heparin in our body. We have inbuilt mechanism to address these issues. But there are times where this is impacted. That's where you need to give the patient exogenously. But these are, it says in the first sentence, synthesized by mast cells or basophils. Do we have mast cells, basophils?
Yes.
Yeah, so we do synthesize it, right? So it's a complex carbohydrate. Our body has made it already. But we have studied and we have optimized it, and we can synthesize it in the lab. Okay. So, but here I'm talking about the natural one. It has complex carbohydrate. It has 10 to 15 aminoglycan chains. So here it's a core protein, you can see, and it has tons of these chains, glycosaminoglycan. Okay, you can see all hanging around like a mesh, tentacles, like tentacles. Okay, so it is very important to know why these chains are important. Okay, what in this chain? What is it important in this chain? Chemical. Okay. So it's composed of alternate saccharide residues. I'm not going to ask you to memorize it, as long as you know that it's a carbohydrate and it has 5 alternating sugars. Saccharides are sugars, right? So here you can see this N-acetylglucosamine, then glucuronic acid, then go on. Continues. So, but then this alternates. All these 5 will alternate again and again, right? So that's what it's gives it a structure, and it's pentasaccharides, means 5. Okay. So the other thing I want to also point out here is this long chain. These long chain makes it high affinity for antithrombin, and not only this long chain makes this ability of heparin to bind to antithrombin, but also there is a sulfate group, as you can see, which is negatively charged. Those are important for it to bind to antithrombin. Okay, so now can you think about the previous question when we say that antithrombin is important, right? Antithrombin, does your body produce antithrombin?
Yes.
Yes, right? Because if heparin is existing, that is going to bind your antithrombin. Why does it need to bind antithrombin?
To dissolve the clots and that's going as well.
I mean, there is blood is clotting, right? In your vessel, in minor clot can be taken care of by antithrombin, right? Because in your vessels, there may be a reason that the clotting is happening. But as long as it's not a major clot, your body can resolve that issue at the site. And for that, it needs antithrombin. And for that, also it needs is your heparin. Because if the heparin is really low, or the level goes really down, then even though the antithrombin is there, the heparin is not available to bind, right? So then you may have problems with dissolving the clot. The clots they could be pathophysiological situation. We don't understand every aspect of our body, right? So in those situations, think about how this is playing a role, okay? So these negatively sulfate group has another role here. It attracts positive charges on platelet factor 4. So there are some other factors. I'm not going to bring every factor in the pathway because it gets too much otherwise. So here, platelets also has a platelet factor 4, and that sulfate group can get attracted to these positive charges on that. And then it forms a large heparin PF4 complexes. That is a problem because now your body can produce antibody against this complex. And sometimes you will see that in patients. And that can lead to this heparin-induced thrombocytopenia. What is thrombocytopenia?
Low thrombos, low or what?
Low platelet, right? Yeah, cytopenia means you're killing the cell, right? So that's what is platelet are low in number because they're dying. And that is being induced by heparin. So you can see now in our body, these are endogenously happening. So if you have these lot of heparin and your heparin is binding because of these sulfate group to platelet factor 4, it may lead to. Does it always lead to? No, because you're not producing too much or you're not binding too much platelet factor 4 maybe is under control. So me and you, a normal human being as a physiology, we are not going to have an induced thrombocytopenia, but some patient may undergo this. So I just wanted to bring that up. And when you do that, like you have to be mindful, like how you're treating those patients. Okay. So as I said, like we are producing it, but as a drug, you need to synthesize it, right? So this is a huge protein, right? So these are being made in pig intestinal mucosa or bovine lung. And that's how they are purified because they can't purify from us in a large quantity. So that's how they do it in industry. But there are also low molecular weight heparins because this is a huge molecule. So do we really need this core protein, which is part of a endogenously produced in the nature in our system? But what scientists have found that you don't need it. Okay, so they remove that and then they proteolyze, converted them into smaller fragment by enzymatic process, and it produces a low molecular weight heparin. There's a drug called that, which is purified in a synthesis in a lab by gel filtration. They filtered these smaller fragments and they can be treated, and they are much smaller, 200 to 30,000 kilodalton in size. There are different fragment sizes, but that's where you can buy it. So now they are much reduced in size. So what does that mean in terms of this table tells you what is the difference between heparin unfractionated, like the big protein, compared to the low molecular weight. So the difference in molecular size is large, it's heterogeneous, mix of long and short chains. It's more homogeneous, produced in the chemically and cleaved enzymatically. Mechanism is where the difference exists, right? This one inhibits both thrombin and factor 10A. And also these long chains that are found in heparin can form a bridge, the antithrombin bridge, and also thrombin, okay? So inhibits both, basically, thrombin and also factor 10A. Whereas in this case, the low molecular weight primarily inhibits factor 10A. And these chains are too small to form the bridge between the antithrombin and thrombin. Okay? So then what happens? Because you think about thrombin and antithrombin, they're also there in our body, right? So if they bind both equally, so they will have this will have an equal activity against both 10A and anti-10, 2A, factor 2A. Whereas this one has higher activity for 10A, factor 10A. Okay? Pharmacologically, this binds to, heparin can bind to many different proteins, many plasma proteins and cells. So the dosing is a problem when heparin. So if you are treating the patient with heparin, you will encounter dosing issues and you need more close monitoring with heparin. But when you are using low molecular weight heparin, it's more predictable because it's less binding to other proteins in the cell. And it can be given subcutaneously at fixed amount, and you are able to, you don't need monitoring in this case with the patient. So this will play a role in the clinic, right? So when do you want to use heparin? When do you want to use low molecular weight heparin? And what are the consequences? And how do you manage that? So mechanism, so where does it act? So this is more of a going back into the pathway. So heparin, you can see the factor 10A and also thrombin, it can inhibit both upstream and downstream. Whereas the low molecular weight is more preferentially for factor 10A. Okay? They both do the job. They both do the job. It's just that one is a larger molecule and the other one is smaller, and the activity wise, one has equal binding for both factor 10A and 2, thrombin and factor 10A. Low molecular weight is more preferential for 10A. So I think that's about, so enhancing the activity of by 1,000 times is by heparin. I think that's, and then you also think about which part of the pathway it's attacking, right? This is the common pathway is attacking in that. So it's not impacting extrinsic or intrinsic, it's more in the common pathway. So there are some adverse effects of this drug, okay? So the adverse effect here is you get bleeding, hair loss, osteoporosis, and you need to now think about reversing that by, you will learn later in your clinical that this drug, protamine sulfate, can help you address that adverse effect. Okay? Because in the pathway we are forming clots, but heparin is doing the opposite, right? It's not letting the clot formation. So that means you have more bleeding, can be as adverse effect. So now you have to reverse your bleeding in your patient. This is like you're solving a problem, but you're creating another problem, right? So that's right. So, okay, let's take a break and review this concept. And we have, let me see how many questions. I think that. So part 2 is 1, 2, 3, 4 questions. So if you guys have already done all the 4, we can start reviewing it. Have you guys done the 4 questions? No? To do?
What?
Okay.
But we're.
So the next, like it has 4 questions in the same guide. Yeah. Those 4 questions.
Oh my god.
And I think that will be done.
D&D?
Yeah. Because A should be high and so low.
Because what?
For A, where it says low, it should say high instead.
Okay.
And then C just doesn't make sense because February is very active.
This is? Yeah, right.
That low. Did you get this one?
Or low molecular.
Mine is telling me it might be
Right. It's obvious C too.
But I select all the other.
Yes.
This one I have.
D?
Yeah, think about first it's high stress, like what's the blood flow? Is it like high flow or low flow? Medium flow. Is it high stress, low stress?
I'm very passionate.
So it's your close. It's A.
You guys really want to sit here.
Which factor is preferentially inhibited by?
Well, all the energy is very low.
At that time,
How can we improve this?
I think a little bit of coffee.
Coffee, should I drink coffee in the class?
For a time in the morning.
keeping obvious.
For a time in the morning.
We're in a break right now, right? Okay.
We're doing the question. This is our break from the lecture.
We'll discuss.
This is happy right
You need more break? I mean, this was a kind of a break, right?
No se apare.
I mean, you can walk. Should we start?
Yes.
Okay. Anyone needs more time? No? Start? Are you guys done? This group two? Yeah? Okay. So group one. Who has not spoken? In group one.
Thou shall speak.
Jose already did.
Yeah. We put B and D.
So you saw select all that apply?
Yes.
Everyone saw select all that apply?
Yes.
Okay, good. That's a big success. Okay, so now group said B and D is the answer. What do your other groups think? Yeah? Anyone has any other opinion? Any comments? What did you learn from this discussion? How did you arrive at B and D? So first think about like what did you thought like when you read this case, what stood out for you?
It's a rupture in the and it's like a so you need the Wilbraham factor to do the platelet aggregation.
Uh-huh.
and then it's gonna, all the platelet aggregation is gonna form like the thrombus. It's gonna form the thrombus.
So yeah, you're getting on the process, right? You're learning the process. But what is the big picture? First, out of this like complex case, what is the simplified thing that you can identify first?
It's formed in the artery.
It's formed in the
Yeah, artery.
artery, right?
It's basically
So is it going to be high stress or low stress?
high stress.
High stress. So first think about a bigger picture whenever you see a complex question. Then getting into the detail will help, because sometimes when you get into too much detail, what you miss is like maybe sometimes you what happens in multiple choice question, you want to arrive sometimes things quickly, right? And sometimes if there's a lot of distraction in the question and you don't need all that information. So if you can identify a few bigger picture, it will help you focus into to getting to the point quicker. So yes, the process is important. So you so that you understand what the question is asking. So now you did not pick A because what stood out in A is to tell you that, oh, this cannot be a choice. Low shear stress, right? And allowing platelet to aggregate easily. I mean, but low shear stress is not the case here, right? So B, primary composition of arterial, because we already mentioned this, we identified as a bigger picture, this is happening in the artery. So this is going to be arterial thrombus, right? So, but is it saying the rest of the sentence is going with it? It's large platelet aggregates, right? That is a choice. That makes sense. So C, anticoagulant like heparin are completely ineffective in the arterial system. Heparin will be ineffective, you think? It will be. What is heparin? What can heparin do? So heparin is given to the patient for what?
Or the clot. It's gonna help the patient with the clot. So we're talking here about the platelet aggregation.
Right. So we're not talking about, yeah. So it's completely a distractor there, right? Even though heparin is used for dissolving, it's an anticoagulant. So in this case, we are not talking about that aspect. So D is the initial event is plaque rupture, which exposes endothelial collagen and BW factor, leading to platelet activation, right? So here we are saying platelet are aggregating, right? The question is why are they aggregating? That is the question, right? So because of all this process is happening, their BW factor is released and it's activated. So this looks good. And this is more like a clinical how, I don't know, in the NAPLEX, this is how it'll appear, but I am trying to replicate that. So now this one should be straightforward, right? Anyone can answer, I think, which one? D? Yes. So it's enzymatic. Low molecular weight is produced by degrading the bigger molecule heparin to smaller fragments. Which clotting factor is preferentially inhibited by low molecular weight? I think I just mentioned 10A, yeah. Oh, I forgot to put animation in there, but that's the answer. So in this one, the anticoagulant effect of heparin is characterized by immediate onset of action upon IV administration. This rapid effect is best explained by its which one? Long elimination half-life, high, the binding and the activation of antithrombin, right? Heparin doesn't have a long half-life, it has short half-life. Okay. I think that's about it for today. We'll talk about more different tomorrow. So should I continue with this or should I just discuss?
No, continue.
Continue with this?
Because it's a healthcare.
How many of you don't want this?
What?
I like.
How many of you don't want it? You don't know?
I think one is good, but two. They kind of agree.
You are the exception. So I will go with the flow. I'll go with the flow, right? Thank you for your time and attention.
Thank you, Dr. Josh.
Yeah.
See you tomorrow.
See you tomorrow.
That's what I